On December 14th, 2024, at 2:17 a.m. Eastern Time, someone at NASA's Jet Propulsion Laboratory updated a public database that most people have never heard of. No press conference, no announcement, no explanation, just a quiet revision to the official data on 3I Atlas, an interstellar object that's been moving through our solar system since October. The changes were subtle, buried in technical language that would mean nothing to most people, but if you know how to read orbital mechanics, if you understand what NASA's classification codes actually mean, these updates tell a story that's remarkable. Within hours, amateur astronomers who'd been obsessively tracking this object noticed the changes and started comparing the old data to the new, and what they found was extraordinary. NASA had fundamentally changed their assessment of what this object is, where it's going, and what might be controlling it. So here's the question. Why would NASA quietly rewrite the official record on an interstellar visitor in the middle of the night, and what were they trying not to say out loud? To understand what happened on December 14th, we need to go back to 1998, to a decision that seemed boring at the time but turned out to be one of the most important transparency measures in astronomy. Congress was worried about asteroid impacts. Hollywood had just released Deep Impact and Armageddon, and suddenly everyone wanted to know if we were tracking these things, could we see a civilization-ending impact coming? NASA's answer was to create a public database called the Small Body Database Browser, where anyone could look up the orbital parameters and physical characteristics of any tracked object in our solar system. It was radical transparency, not because NASA was particularly noble, but because they wanted to avoid accusations of hiding information about potential threats. If an asteroid was going to hit Earth, they wanted the data public so nobody could claim cover-up. This database became the authoritative source for asteroid and comet data, used by professional astronomers, mission planners, and amateur observers to point their telescopes, and it operated under a simple principle. When new observations came in and orbital calculations were refined, the database would be updated, usually with minor, routine changes. But the database had another feature that NASA probably didn't think much about at the time. It kept revision histories, every change was recorded and time-stamped, old versions could be compared to new ones, and this becomes important later. Fast forward to October 2024, when the Atlas survey telescopes in Hawaii detected something unusual and gave it the designation 3I Atlas. And that 3I immediately attracted attention because I stands for interstellar. This was only the third confirmed interstellar object ever detected. The first was Oumuamua in 2017, which sparked years of controversy when Harvard astronomer Avi Loeb suggested it might be artificial based on its bizarre properties. The second was Comet Borisov in 2019, which was more conventional but still fascinating, so when 3I Atlas appeared, people were primed to pay attention. Amateur astronomers with serious equipment started tracking it obsessively, and some of them began keeping detailed logs of every change NASA made to the database entry, every small update to the orbital parameters, every revision to the physical characteristics. They were building their own revision history, independent of NASA's official one. The initial data seemed straightforward. 3I Atlas was classified as a hyperbolic comet about 240 meters across, on a trajectory that would take it past the Sun and back out to interstellar space. Early observations suggested a faint coma typical of comets. Everything looked normal, or at least as normal as an interstellar visitor could be, but within weeks, things started getting strange. Let's walk through what the database said about 3I Atlas before December 14th, because you need to understand the baseline to appreciate what changed. By early November, the official entry painted a clear picture. This was an interstellar comet on a hyperbolic trajectory with a perihelion, its closest approach to the Sun, of about 0.4 astronomical units, about 60 million kilometers closer than Mercury's orbit. The object would swing around the Sun in early December and then head back out toward interstellar space, exiting roughly in the direction it had come from, toward the constellation Lyra. The physical characteristics were listed as typical for a comet: dark surface with an albedo of 0.04, meaning it reflected only about 4% of sunlight, normal for comets, which are basically dirty snowballs with carbon-rich surfaces. The rotation was listed as undetermined, likely chaotic, standard for small, irregular bodies that tumble unpredictably through space, and there was mention of a possible weak coma detected early on, though later observations hadn't clearly confirmed continued activity. Then came November 28th, when multiple observatories detected a clear change in the object's velocity. It decelerated over about 17 minutes, altering its trajectory, and this was added to the database on November 30th with a note that read, "Trajectory adjustment detected, likely asymmetric outgassing event." That phrase, likely asymmetric outgassing, is doing a lot of work because it's providing a conventional explanation without actually confirming that outgassing had been observed. It's the kind of carefully hedged language organizations use when they want to acknowledge something happened without committing to what it means. The database stayed relatively stable after that through early December. The orbital parameters reflected the new post-maneuver trajectory. The classification remained hyperbolic comet, and if you were casually checking, you'd think everything was settled. Weird comet, unusual behavior, but ultimately explainable. Then came the December 14th update, and the changes were extensive. First, the classification changed from hyperbolic comet to hyperbolic object. Classification under review. And NASA doesn't use under review lightly. It's the designation for objects that don't fit existing categories. It's an admission of uncertainty. But the classification change was just the beginning because the orbital parameters had been substantially revised. The perihelion distance was now listed as 0, 6 astronomical units instead of 0. 4. 50% farther from the Sun than previously calculated, and the exit trajectory no longer pointed back toward Lyra, but instead showed the object heading toward the outer planets, specifically on a path toward Saturn in approximately 7 months. Let me emphasize what this means. You don't casually revise an object's perihelion by 50% because orbital calculations are extremely precise. So if NASA is changing the perihelion by such a large amount, it's because the object is not where the original calculations said it should be. The object has deviated from its predicted path significantly. And here's what's remarkable. There was no note explaining this second trajectory change. The November 28th maneuver got a note about outgassing, but this larger deviation got no explanation, just updated numbers showing the object was somewhere it wasn't supposed to be. The physical characteristics had also been dramatically revised, with the albedo changing from 0.04 to 0.6, a 15-fold increase in reflectivity, and dark comet surfaces don't suddenly become highly reflective. There was a new entry, morphology, geometric profile indicated by light curve analysis, regular rotation period 4, 3 hours, non-chaotic spin axis, and every part of that is significant because geometric profile means regular shapes, flat surfaces, symmetry, while natural objects are irregular and lumpy, and regular rotation period means it's spinning steadily, not tumbling, while non-chaotic. Spin axis means it's stable, like a spacecraft would be. The note section added new entries, one saying the surface composition was inconsistent with known natural materials, another officially acknowledging that multiple facilities had confirmed radio emissions at specific frequencies with temporal structure, meaning the signals had patterns, and the final note added December 14th simply said, object trajectory and physical characteristics, revised based on extended observational dataset, classification review in progress. That's it. No explanation of why the trajectory changed, no discussion of what the high albedo means, no interpretation of the radio signals, just an acknowledgement that things have changed and they're thinking about it, and then silence. To understand why these changes matter, we need to talk about how orbital mechanics works, because when you track an object in space over time, you're solving a math problem. Given the object's position and velocity, and the gravitational forces from the sun and planets, where will it be in the future? And this is deterministic with no randomness. So if you know the initial conditions well enough, you can predict the trajectory with extraordinary accuracy, which is how NASA can tell you exactly where Mars will be 50 years from now. So when an object deviates from its predicted path, there are only a few explanations. Either your measurements were wrong, which becomes unlikely as you gather more data, or there's an unaccounted gravitational source, which we can rule out, or the object is experiencing non-gravitational forces. For comets, this is well understood. Solar radiation heats the surface, ices sublimate, and jets of gas act like rocket engines in what's called the rocket effect, observed for decades. But here's the key. Cometary outgassing is observable. You can see the coma and tail, you can measure it spectroscopically, you can image the jets, and the acceleration is chaotic because it depends on which part of the irregular surface faces the sun as the comet tumbles. 3I Atlas showed none of this, no visible coma, no spectroscopic evidence of volatiles, and the trajectory changes weren't chaotic but precise, with the November 28th maneuver lasting exactly 17 minutes and altering the path in a specific direction, and that's not how outgassing works, that's how powered flight works. Now let's talk about albedo, which is simply how much light an object reflects. Comets are very dark, typically 0, 0.3 to 0, 0.6 because their surfaces are covered in carbon-rich organic molecules, essentially tars and soot. An albedo of 0.6 is exceptionally high, and the only natural objects that reflective are fresh ice, which wasn't present on 3I Atlas or polished metal. But even metal surfaces in space get weathered and cratered and don't stay shiny. An albedo of 0.6 suggests something fresh, protected, or actively maintained, and combined with the geometric morphology, the regular shapes indicated by light curve analysis, you start running out of natural explanations. The rotation data adds another layer because natural small bodies typically tumble chaotically, but 3I Atlas shows a clean 3-hour rotation period around a stable axis, and for a natural object to rotate stably, it needs to be very symmetrical or rotating around its longest axis. But the light curve suggests it's not particularly elongated, so how is it stable? In spacecraft, this is achieved through gyroscopes and reaction wheels that actively maintain orientation. So if 3I Atlas is rotating stably despite not being naturally stable, it suggests active control. When 3I Atlas was first detected, the assumption was straightforward interstellar comet, and we'd seen Oumuamua behave strangely, so maybe interstellar objects are just weirder than local ones. Different formation environments, different compositions, different behaviors. The scientific community wanted natural explanations because extraordinary claims require extraordinary evidence, and claiming something is artificial is about as extraordinary as it gets. The November 28th maneuver was explained as outgassing even though no outgassing was directly observed. It was the most conservative interpretation because comets can do this, so probably that's what happened. But as more data came in, that interpretation became harder to maintain. The high albedo doesn't fit, the geometric morphology doesn't fit, the stable rotation doesn't fit, and the radio emissions definitely don't fit because natural radio sources like pulsars produce broad spectrum noise. While 3I Atlas was producing narrowband signals at 1420 and 2840 MHz, the hydrogen line and its harmonic, frequencies that SETI researchers monitor specifically because any technological civilization would recognize their significance. Each individual anomaly could potentially be explained away. Exotic composition for the albedo, unusual shape for the geometry, coincidental stable rotation, piezoelectric effects for the radio emissions, but all of them together in one object, following a trajectory that looks designed? The probability space narrows considerably. And what people believed in October was that this was just another space rock, but what the data increasingly suggests is something very different. So we're back to December 14th, and that quiet database update, NASA had been watching this object for 2 months with data from dozens of observatories including optical telescopes, radio telescopes, and infrared observations. They'd calculated and recalculated the trajectory, analyzed the composition, the rotation, the morphology, and at some point, someone made a decision that the old classification wasn't working. The old orbital parameters were demonstrably wrong. The object wasn't where it was supposed to be, and it wasn't what they thought it was. But instead of announcing this, instead of holding a press conference to discuss these remarkable findings, they updated the database at 2 a.m. on a Saturday and said nothing. The revision history shows the changes. The amateur astronomy community noticed immediately, but NASA stayed silent with no press release, no interviews, no educational content explaining these observations to the public, and that silence is perhaps more significant than the data itself. So why did NASA quietly update the data on 3I Atlas? The simple answer is because they had to. Scientific integrity requires publishing your findings. The database exists to provide accurate information, and when observations show that previous data was wrong, you update it because that's how science works. But why do it quietly? Why no explanation? I think there are several factors at play, including institutional caution, because NASA is a government agency that's careful with public messaging, especially on topics that could be sensationalized. And if 3I Atlas is exhibiting properties that suggest it might be artificial, that's not something you announce casually, but something that requires coordination with other agencies, international partners, and careful consideration of how to communicate it responsibly. Second, scientific uncertainty. Even with all the anomalous data, there's still no definitive proof of what this object is, and scientists are trained to hedge, to avoid jumping to conclusions, to wait for more evidence. So the phrase classification under review captures this perfectly, because they know it doesn't fit the comet category anymore, but they're not ready to say what category it does fit. Third, there might be internal disagreements because science is messy, scientists argue, and when you're dealing with data this anomalous, there will be fierce debates about interpretation. Some researchers probably still think there's a natural explanation they just haven't found yet, while others might be more convinced by the artificial hypothesis. So keeping quiet while those debates play out internally makes sense from an institutional perspective. Fourth, and perhaps most importantly, there's the question of what comes next, because if this is a probe, if it's here gathering information, if it's maneuvering with purpose towards Saturn, then what? Do you try to communicate with it? Do you send a mission to intercept it? Who makes those decisions? Because these are questions without precedent that require time to think through. So NASA did what large bureaucratic organizations do when faced with paradigm-shifting information. They moved cautiously, updated their records to maintain scientific integrity, and kept their conclusions private until they figure out how to handle this. The data is public, technically transparent, but presented in language so technical that most people won't understand its implications, so it's transparency and opacity at the same time. Here's what we know for certain. An object from beyond our solar system is currently moving through our neighborhood. It has changed its trajectory at least twice in ways that don't match natural comet behavior. It has physical properties including geometric morphology, stable rotation, and high reflectivity that are inconsistent with known natural objects. It's transmitting radio signals at mathematically significant frequencies, and NASA has quietly acknowledged all of this by changing its classification to under review and revising its predicted path to show it heading towards Saturn. What we don't know is what this means. Is 3I Atlas a probe sent by another civilization? Is it debris from some ancient project we can't imagine? Or is it a natural object operating on physical principles we simply haven't encountered before? Because the data can't definitively answer that question yet, but what's clear is that we're watching something extraordinary unfold in real time. The quiet database update on December 14th wasn't a cover-up because the information is public and anyone can access it, but it also wasn't an announcement. It was a middle path maintaining scientific integrity while avoiding the enormous complications of declaring that we might be observing artificial technology from beyond our solar system. And a strange way, that quiet update in the middle of the night tells us more about where we are as a civilization than any press conference could, because we're at the threshold of a potential revelation, but we're not quite ready to walk through the door. We're updating our databases, revising our models, reviewing our classifications, all while carefully not saying out loud what the data increasingly suggests. And in a few months, 3I Atlas will reach Saturn, and what happens then might force the conversation NASA seems reluctant to have. Until then, the data sits in that public database, updated but unexplained, waiting for the world to catch up to what it's quietly telling us, because sometimes the most important changes happen without fanfare. In the technical language of orbital parameters and classification codes, updated at 2 a.m. when nobody's supposed to be watching, but people are watching, and the silence is starting to sound a lot like an answer.